septic tanks consist of 1 or 2 chamber tanks that store the water for a few days, and there the water receives a treatment by means of microbes. Despite of being a technology widely used, they are often not regulated and poorly maintained. When not emptied, what you have is a buildup of sludge, and you basically start to discharge raw sewage into the environment and also generate emissions from the sludge. 1.5 methane, 5.5 carbon dioxide. We are conducting an experiment that will last 8 months of operation in a Scottish water treatment facility. The septic tanks are operated at different temperatures, up to 30 degrees, and we are testing how much emissions are being produced and also what's the quality of the treated water.
The main aim of our experiment is to make the first detailed study of the emissions from septic tanks. Methane emissions from septic tanks have in the past been seen as a problem. We believe that we can create a bioreactor that sits on top of the septic tank, which is populated by a group of organisms that effectively eat the methane and produce a less harmful gas, CO2. In the process, they create heat. So we think we can recycle that heat to an air source heat pump and reduce people's electricity bills.
I'm really interested in research that could lead to environmental benefit, and this is a way that I can use my skills in electronics to do that. I can control the experiment remotely. The valves that feed water from the holding tanks into the septic tanks, they're connected to a microcontroller which is connected to the internet, so I can change the schedule of when the water flows.
The research is funded by an EPSRC programme grant and would not have been possible without the collaboration with Scottish Water and their commercial wing, Scottish Water Horizons in particular. This experiment is the first in a series of experiments where we want to move towards novel septic tank technologies. Ultimately then the challenge is to implement that in a real house. So that's our next major challenge.